Good morning students. Last class we discussed some of the important compounds of 17th group elements. Those are chlorine and hydrogen chlorides. Then today's discussion is interhalogen compounds. Interhalogen compounds. Interhalogen compounds are the compounds formed by the combination of halogens among themselves are known as interhalogen compounds. Interhalogen compounds are the compounds formed by the combination of halogens among themselves are called as interhalogen compounds, and these interhalogen compounds are of four types, and these are represented as XX dash, XX-3, XX-5, XX-7, and in this X is a halogen of larger atomic size and lesser electronegativity. Then whereas X dash is the smaller atomic size and higher electronegativity. Higher electronegativity ಯಾವುದು ಇರ್ತದೆ? X dash ಇರ್ತದೆ. X is the lower electronegativity. Compounds formed by the combination of halogens among themselves are known as interhalogen compounds. These are called as interhalogen compounds, and interhalogen compounds are of four types. Interhalogen compounds are of four types and are represented by the general formulae as XX dash, XX dash 3, XX dash 5 and XX dash 7, where X and X dash are both are the halogens, but one of them in this interhalogen compound is lower electronegativity and higher atomic size, and another one is smaller atomic size and higher electronegativity, where X is a halogen. X is a halogen of larger atomic size and lower electronegativity, whereas X dash is a halogen of smaller atomic size and higher electronegativity. ಇದರೊಳಗೆ ಏನಪ್ಪ ಅಂತಂದ್ರೆ X is the this is X dash and this one is X. X is always larger atomic size and lower electronegativity, and X dash is the smaller atomic size and higher electronegativity, and the interhalogen compounds are the compounds formed by the combining or combination of halogens among themselves. These are called as interhalogen compounds, and these interhalogen compounds are of 4 types: XX dash, XX dash 3, XX dash 5 and XX dash 7. Next, coming to preparation of interhalogen compounds. Preparation of interhalogen compounds. Here the interhalogen compounds are prepared either by direct combination of halogens among themselves or by the action of halogen on lower interhalogen compounds. Lower interhalogen compounds ಜೊತೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ halogens ಏನಪ್ಪಾ ಅಂದ್ರೆ react ಆಗ್ತಾವ ಅಥವಾ the halogens among themselves to combine to form interhalogen compounds, and the product form mainly depends on the reaction condition. Reaction condition ಮೇಲೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ product formation depend. Interhalogen compounds are prepared either by direct combination of halogens among themselves or by the action of a halogens on a lower interhalogen compounds. Lower interhalogen compounds ಜೊತೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ halogens interact. And some of the preparations of interhalogen compounds and the product mainly depends on the reaction condition. First, for example, first one is Cl2 plus F2 at about 473 Kelvin temperature, and these chlorine and fluorine are taken in the equimolar proportion at about 473 Kelvin temperature to form ClF. It is of the type XX dash. Second one is Cl2 reacts with excess of fluorine. Chlorine reacts with excess of fluorine at about 573 Kelvin temperature to form 2ClF3. This compound is called chlorine monofluoride. This is called ClF is called chlorine monofluoride, and this is called chlorine trifluoride. Trifluoride. Similarly, ClF3 reacts with F2 it forms ClF5. This is called chlorine pentafluoride. Or the ClF reacts with F2, it forms ClF3. Another example is bromine reacts with fluorine in the equimolar proportion. It forms 2BrF. Bromine monofluoride is formed. Another example, Br2 reacts with excess of fluorine. It forms bromine trifluoride. And similarly, another example or preparation of interhalogen compound, iodine reacts with fluorine. It gives 2IF3, iodine trifluoride. And I2 reacts with excess of F2 at 293 Kelvin temperature to form IF5, iodine pentafluoride. Another example is I2 reacts with excess of F2 at 293 Kelvin temperature to IF7. This compound is called iodine trifluoride. This one is iodine pentafluoride. This is iodine heptafluoride. These are the some of the interhalogen compounds are prepared by direct combination of halogens among themselves or by the action of halogen on lower interhalogen compounds. One more example is that fluorine reacts with ClF. It gives ClF3. Fluorine or halogens on action on the lower interhalogen compounds. These can also be prepared by the action of halogens on lower interhalogen compounds. These are the some of the preparations of interhalogen compounds by two different methods, by direct combination or by the action of halogen on lower interhalogen compounds. Next, coming to important properties of interhalogen compounds. Important properties of interhalogen compounds. Here, some of the properties of interhalogen compounds, in that first one is they are all covalent molecules and are diamagnetic in nature. All the interhalogen compounds are covalent molecules and are diamagnetic in nature. First property is they are all covalent molecules and are diamagnetic in nature. This is the first property of interhalogen compounds. And they are volatile solids or liquids at 298 Kelvin except CLF. CLF one bit chlorine monofluoride is a gas, and all other interhalogen compounds at 298 Kelvin are volatile solids or liquids. They are volatile solids or liquids at 298 Kelvin except CLF, which is a gas. This CLF at 298 Kelvin is only gas, and rest of the interhalogen compounds are volatile solids or liquids at 298 Kelvin. Then third important property of interhalogen compounds is their melting point is higher than that of halogens. Melting point of interhalogen compound is more than halogens, and this melting point increases with increase in their difference of electronegativity. Interhalogen compound dolage two halogens irtave. The electronegativity difference in interhalogen compound increases, their melting point is also increases, and these interhalogen compounds having higher melting point than halogens. Their melting points are higher than the halogens and increases with increase in the difference of electronegativity. Electronegativity difference is more means these interhalogen compounds having higher melting point, and electronegativity difference increases, melting point is also increases. Then fourth important property is, this is a very important point. Generally in your theory examination, they will ask why interhalogen compounds are more reactive than halogens, or ICl is more reactive than I2. Why? Interhalogen compounds are more reactive than halogens except fluorine. Fluorine ಬಿಟ್ಟು ಉಳಿದೆಲ್ಲ interhalogen compounds ಏನಪ್ಪ ಅಂತಂದ್ರೆ more reactive ಇರ್ತವೆ. ಫ್ಲೋರಿನ್ ಒಂದು ಬಿಟ್ಟು ಉಳಿದದ್ದು ಎಲ್ಲ ಹ್ಯಾಲೋಜನ್ ಕಿಂತನೂ interhalogen compounds are more reactive. Interhalogen compounds are more reactive than halogens except fluorine. Except fluorine, interhalogen compounds are more reactive than halogens. Ella halogen kintanu interhalogen compounds more reactive except fluorine. This is because the bond dissociation enthalpy in interhalogen compound is less than halogen, and this bond dissociation enthalpy is less due to the bond between two dissimilar halogen atom is weak, and the bond between two similar halogen is strong. Since the bond between two dissimilar halogen atoms is weaker than the bond between two similar halogen atoms. Therefore, bond dissociation enthalpy of interhalogen compounds is less than that of halogens except fluorine. ಇದೇನಪ್ಪ ಅಂತಂದ್ರೆ 1 mark give reason or why interhalogen compounds are more reactive than halogens ಕೇಳ್ತಿರ್ತಾರೆ, ಅಥವಾ simply ICl is more reactive than, ಹೆಂಗೆ ಕೇಳ್ತಾರಪ್ಪ ಅಂತಂದ್ರೆ ICl is more reactive than I2. Why? The reason for this is same. Interhalogen compounds are more reactive or ICl is more reactive than I2. Why ಅಂತ ಕೇಳಿದ್ರು ಏನಪ್ಪ ಅಂದ್ರೆ reason is only this. Then next important property of interhalogen compounds is all the interhalogen compounds undergo hydrolysis, giving halide ions formed by the halogen of higher electronegativity and smaller size, and oxohalate ion formed by halogen atom of lower electronegativity and larger size. Illenpa andre two types of ions are formed when interhalogen compounds are hydrolyzed. Hydrolyzed ಆದ ಕೂಡಲೇ ಎರಡು ಟೈಪ್ ಆಫ್ ions ಬರ್ತವೆ. One is halide ion, that is from higher electronegative and smaller atomic size of halogen ಇಂದ ಏನಪ್ಪ ಅಂದ್ರೆ halide ion formation. Then next one is oxohalate ion is formed by halogen having larger atomic size and lower electronegativity. All the interhalogen compounds undergo hydrolysis giving halide ion formed by the smaller size formed by larger electronegativity of halogen having smaller size, larger or higher electronegativity. Higher electronegativity of halogen having smaller size and oxohalide ion formed by the lower electronegativity of halogen having larger size. These are explained by the following reactions. Let us consider XX dash type of interhalogen compound on hydrolysis with water. It forms HX dash plus HOX. Two ions are formed. One is halide ion, another one is oxohalide ion. And if XX dash on hydrolysis with water, it forms halide ion. This is halide ion, and this one is hypohalite ion. This is hypohalite ion is formed. Another XX-3 on hydrolysis with water, it forms HX dash plus HXO2. This is halide ion. Halide ion is formed by halogen atom of higher electronegativity and smaller size, and oxohalite ion is formed by halogen atom having lower electronegativity and larger atomic size. This is halide ion. Then X-5 on hydrolysis with water, it forms halide ion plus HXO3. This is halate ion. This is halate ion. And lastly, XX-7 on hydrolysis with, this is 3, water, it forms 7HX-, this is halide ion, plus HXO4, this is perhalate ion. These are the ions obtained on hydrolysis with water. Hydrolyze aad ಕೂಡಲೇ ಏನಪ್ಪ ಅಂದ್ರೆ there are two types of halide ions, halide ion as well as oxohalate ion obtained, that is depends on interhalogen compounds of XX- type interhalogen compound on hydrolysis gives halide ion and hypohalite ion. XX-3 type of interhalogen compounds on hydrolysis gives common halide ion and halite ion, and XX-5 on hydrolysis gives halate ion, and XX-7 on hydrolysis gives perhalate ion. These are the some important properties of interhalogen compounds. Next, coming to structures of interhalogen compounds. Next is structures of interhalogen compounds. The structures of interhalogen compounds are explained on the basis of VACPR theory. This was explained on the basis of VACPR theory. ಈ ಥಿಯರಿ ಮೇಲೆ ಏನಪ್ಪ ಅಂತಂದರೆ the structures of interhalogen compounds are explained. Here there are 4 different types of interhalogen compounds: XX-, XX-3, XX-5 and XX-7. And here first is type of interhalogen compound. Next is hybridization of central halogen geometry then last column is true structure of interhalogen compound. There are 4 different types of interhalogen compounds. In this, first one is XX dash type, second is XX dash 3, third one is XX dash 5, fourth one is XX dash 7. These are the 4 different types of interhalogen compounds, and the hybridization of the central halogen is, let us consider X. Here now examples examples of the type XX dash, XX dash 3, XX dash 5 and lastly XX dash 7. Here ICl, CLF, BRF and here CLF3, BRF3, CLF5, IF5, IF7. These are the examples of different types of interhalogen compounds, and the hybrid state of central X is, for XX dash is sp3. That is, we already explained in the oxidation state, ground state electronic configuration of X is this is NS, NP and ND. This is a vacant d orbital, and ground state electronic configuration of X is, the valence shell electronic configuration is NS2 NP5, and there is only one unpaired electron, and this forms covalent bond with X dash and it forms sp3 hybrid orbitals. It forms sp3 hybrid orbitals, and the structure of this is, linear. Structure is X, X dash, which contain 3 lone pairs, and the structure of this is, geometry is tetrahedral geometry. Tetrahedral geometry, and the true structure of interhalogen compound is linear structure. Then second one is XX-3. Here first excited state electronic configuration of X is in the first excited state of X, one of the paired electron is shifted to empty d orbital and it forms 5 hybrid orbitals. Those are sp3d hybrid orbitals are formed, and there are 3 unpaired electrons and forming covalent bond with X dash. And the structure of this is, geometry is hybridization of XX-3 of central X is sp3 dehybridization, and sp3 dehybridization of central X geometry is trigonal bipyramidal, and but the structure is different than geometry because which contain 2 lone pairs. ಇದರಲ್ಲಿ 3 lone pair ಅದಾವ, ಇಲ್ಲಿ 2 lone pair ಅದಾವ. ಅದಕ್ಕೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ the structure of this is like this. This is X, and 2 lone pairs are occupied in the equatorial position, X dash, and the actual structure of XX-3 type of interhalogen compounds is T shape. This is T shape of molecules. T shape because 2 lone pair of electrons occupying in the equatorial position and 1 X dash is present in the equatorial position and 2 X dash atoms are in the axial position, and the structure or shape of this molecule is T shape. Next, coming to second excited state electronic configuration of X is in the second excited state, the 2 paired electrons in the p orbitals are unpaired and shifting of vacant d orbitals, and the second excited state electronic configuration is like this, and it forms 5 unpaired electrons and forming 5 equal energies of hybrid orbitals, that is sp3d2 hybrid orbitals are formed, and these forming 5 covalent bonds with X dash. And the structure of this is, it contains 1 lone pair of electron and sp3d2 hybrid state of central atom forming octahedral geometry, but the shape is different because of 1 unpaired electron is present. This is X dash, x dash, x dash, here also x dash, and this is the lone pair. This is the geometry of this molecule is octahedral geometry, but the shape of the molecule is different because of which contain one lone pair of electron and it is a square pyramidal shape. Hybrid state of X central X is sp3d2 hybridization and geometry is octahedral, then it is a square pyramidal. Shape or structure of the molecule is square pyramidal. Then last one is third excited state electronic configuration of X is all the paired electrons of halogen is unpaired and shifting to vacant d orbitals. Here there are 3 paired electrons and these 3 paired electrons are unpaired and shifting to the vacant d orbital in the third excited state, and their excited state electronic configuration is like this, and there are 7 unpaired electrons are present in the hybrid orbital and 7 hybrid orbitals are formed, and these forming 7 covalent bonds with X dash molecules. And the structure of this is the structure of XX-7 is pentagonal bipyramidal, and geometry as well as structure of this compound is same because there is no unpaired electrons. X dash, X dash, X dash, X dash, X dash, these are in the pentagonal form. And 2 of X dash. This is the pentagonal bipyramidal geometry as well as shape. Hybridization is sp3d3, then geometry is pentagonal bipyramidal. Geometry is shape is also same, pentagonal bipyramidal, because this type of molecules does not containing lone pair of electron, hence its geometry as well as shape or structure of the molecule are same. If the lone pair of electrons are present, then their geometry as well as the shape of the molecules are different. These are the some of the shapes, structures of interhalogen compounds. ಇದೊಂದು ಗೊತ್ತಿದ್ರೆ ನಮ್ಗೆ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಎಲ್ಲಾದ್ರದ್ದು ಸ್ಟ್ರಕ್ಚರ್ ಡ್ರಾ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತದೆ. ಹೌದಾ? ನಾ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಜನರಲ್ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ x dash ತಗೊಂಡೆ ಸ್ಟ್ರಕ್ಚರ್ ಡ್ರಾ ಮಾಡಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ClF, central Cl which contain 3 lone pair of electrons. Here X-3 means ClF, F which contain 2 lone pair of electrons, ClF3. Then here F5, and one lone pair is, and here I have 7. Here 1, here 1. This is the pentagonal bipyramidal geometry of IF7. And some of the uses of interhalogen compounds. These interhalogen compounds are generally used as a non-aqueous solvent. Ivenpa antandre these are volatile solid or liquid phase nolage irtave at 298 Kelvin, and these are generally used as a non-aqueous solvents. And interhalogen compounds of fluorines are generally used as a good fluorinating agents. ClF3, then BrF3, these are generally used as a good fluorinating agents. Fluorine, interhalogen compounds of fluorines are generally used as a good fluorinating agents. And ClF3 and BrF3 are generally used to prepare uranium hexafluoride by enriching uranium 235. These are the some of the uses of interhalogen compounds, and this completes 17th group elements, and next class we will start 18th group elements called noble gases. Thank you.